Hello, everyone, and thank you all for joining us. The views, opinions, and technical analysis presented during this webinar are those of Asaclean purging compounds and are not necessarily those of UL. The appearance of this content on UL sites does not constitute an endorsement by UL or its affiliates. Today's webinar is Beyond Efficiency, Pioneering Solutions for a Greener Future. It is presented by Asaclean. Your presenter today is Chris Melchior. Chris is a business development manager with Asaclean Purging Compounds. He specializes in chemical purging compounds and concentrate grades. Before joining Asaclean in 2015, he worked for 16 years for Novachem. My name is Derek Batcher with UL, and I'll be moderating today's webinar. Now I'll turn it over to Chris. You ready to begin?
Yes, thank you, Derek. Thank you, everyone, for taking the time to join us today. As Derek mentioned, I've been in the purge compound industry for several years, dating back to 1995. I was fortunate enough to work with some of the pioneers and developers of purge compound, which really began in the late 80s. I've been with Asahi selling Asaclean products and servicing Asaclean products since 2015, and I'm hoping that you find this information informative. A little bit about Asahi Kasei. We are a global conglomerate operating in key markets like materials, home, healthcare, and obviously plastic. We're a $20 billion revenue, 37,000 employees globally, based out of Tokyo, Japan. Basically, what all this means, guys, is we have resources. We have some very, very intelligent people working for our company. As a matter of fact, one of our scientists even invented the lithium-ion battery. So if I don't have answers for any of your questions, I certainly have the resources to get it. We've been the worldwide leader in commercial purge compounds for several years, and we service customers in more than 70 countries. So what are our goals today? We're going to basically give you the basic understanding of purging, translate the basics in the 6 applications for optimized production, and how to implement a purge program. First, we'll start with the basics of purging. What are purge compounds? Purge compounds are designed to clean thermoplastic processing equipment. It could be injection molding. It could be extrusion and all facets of extrusion. It could be pipe, profile, sheet, blown film, blown molding, every single type of plastic processing we help. Purge compounds contain a base resin and other additives to optimize and clean your screw barrel extruder downstream plumbing thoroughly and quickly. And they're used by processors across the industries to reduce downtime and scrap. Some of the variables that we need to determine on which grade selection, because we do have 23 different grades of material, we're going to need to understand what your process is. If you're an injection, extrusion, or blow molder, the kinds of resins that you're processing, whether it's a commodity engineering grade material or a super engineering grade material, such as PEEK, Ultem, LCPs, Riton, so forth. We're going to need to understand what we're actually trying to accomplish here. Are we cleaning the die, the downstream equipment? Are we doing a screw pull? Everybody's situation is uniquely different. Even though they could be classified in the same arena, everybody's equipment is different, everybody's resins are different, everybody's processing is a little bit different. So we need to get a thorough understanding of where the problem lies. And then what we're going to determine is the type of purge compound necessary to get the job done. Obviously, there are mechanical type purge compounds that you're familiar with, chemical type, and concentrate versions, which we'll get into a little bit later. We'll first talk about mechanical purge compounds. Mechanical purge compounds have been around a very, very long time. Those were primarily the first types of purge compounds that people used when purge compounds came into play. The neat thing about mechanical purge compounds is, again, they're simple to use. Typically 2 to 3 system capacities of a mechanical purge compound are required to clean your equipment. For example, in an injection molder, if you have an injection molder that we're going to say the screw and barrel holds 1 pound, and that might be high for some machines, but we're just going to use that as a round number. it's going to typically take 2 to 3 pounds of a mechanical purge compound to get the job done. They require no soak time. The object is to move the mechanical purge compound through the screw and barrel of the machine with the screw forward in the injection molding segment anyway, as fast as you can. So as far as a purge time, they're very, very short in duration. Chemical purge compounds, little different animal. The reason why I really like chemical purge compounds, especially in extrusion applications, is because there's a lot going on chemically. Chemical purge compounds do expand. In addition to that, we create steam with the use of a hydrate, and the material will foam. In addition to that, the formulation contains some mild detergents and some mild abrasives, which will also help you get the job done very, very effectively. With chemical type purge compounds, the object is different from that of a mechanical purge compound, where once the system is completely full, rather than run it very, very quickly, you're going to run it very, very slowly to get the chemical reaction to do what it needs to do. Once the material expands and the chemical reactions take place, that really forces the purge compound in negative flow areas and dead spots very, very effectively. So even when you're talking about systems that are extremely complicated, whether that they have a static mixer, a melt pump, complicated dyes, such as in a blown film environment, this material will really get into those areas and clean the material and clean the system effectively. Purging concentrates. We recently have resurrected this product because the need had become so great. Basically, what we're doing with a concentrate is we're taking all the active ingredients that we have in our chemical purge compounds and separating that from a carrier resin. The reason why we do that, let's say in the case of a blow molder, who primarily will be manufacturing high density polyethylene. Well, if the carrier resin in our ready mix product is a high density polyethylene, you certainly don't need to be buying polyethylene from us. You're buying it by the rail car. So if you were to buy our concentrate and mix that with your production material, it's going to save you much more. It's going to save you money, number one. And the cool thing about a concentrate is that you can play with the mix ratio depending on the severity of the problem that you have. We have found that a 20% mix ratio of our concentrate to 80% of your production material will typically get the job done in most cases. Conversely, if it's a really, really bad situation, let's say if you're dealing with a color change going from a highly loaded carbon black to a white to a clear, you have the opportunity to ramp that up to maybe 30 or 40% to get even increased cleaning capability out of the product. On the other side of the coin, if it's not that difficult and you need to use it as a shutdown purge, let's say, you can drop that mix ratio from 20 down to 15 or 10% and still get the job done effectively. So you control the mix ratio, you control the purging power of the formulation that you're going to develop. Typical problems that injection molders face, and if you are an injection molder, you probably already know this, but we need to really clean the screw and barrel, the nozzle, the check ring. Our purge compounds, whether they be mechanical or chemical in nature, will clean the hot runners or hot manifolds. When it comes to a chemical type purge compound, you can typically use them at the operating temperature of whatever resin that you're processing. And if your tool gives you problems, such as a hot runner or hot manifold, we would increase the heat slightly there to increase the purging power or cleaning capability of the material. And by the way, injection molders, the majority of all our purge compounds are moldable. Extrusion, as I mentioned earlier, Chemical purges work extremely well in extrusion applications. Why? Again, because they expand in low pressure environments, works well in twin screw applications. And if you do have vented barrels, it'll clean the areas close to the ports in the vent. One thing that we really need to stress is following the directions. Believe it or not, I can't tell you how many times I'm in plants where customers have utilized our products over the years. And because of either personnel changes or what have you, we would start out a certain way, maintaining the procedures to give you the best performance out of the product. And over periods of time, we see that those procedures start to slip, or we see that people try to do things their own way. Guys, it's only shooting yourself in the foot. Once we develop a standard of performance, it's basically because you're using the product as directed or by the instructions that we provide you folks. Now, the procedures that we do provide you, they're for the majority of the situations. So a lot of times what we do initially when we help you refine a purge process is we tweak those procedures. And sometimes we might need to do a couple little extra things based on your present situation, or we could minimize those procedures. But the bottom line is once we have them nailed down and are able to generate the best results with our purge procedures, please stick with them. Other things that could hurt your efficiency. A lot of folks that we come in contact today before they come with us or come on board with us is they'll be using virgin or regrind to purge with. Now, yeah, it can be relatively effective, but you have to keep in mind that virgin and regrind are not designed to clean. You're going to go through an awful lot of it. And even though it might be considered scrap, it's really not scrap. On an average, we save 80% of purging with our materials versus using a virgin or a regrind. Auto purge settings. Whether it's injection molding or extrusion, there's always typically an auto purge setting. Those also are not the best way to go. Our procedures are designed to be followed. The machines aren't capable of doing that a lot of time. One size does not fit all. And also auto purge does not account for cost per purge. We're now going to get into 6 applications that we typically have to deal with. If you don't know it already, these are the top 6. We're going to help you with color changes and material changes, contamination or black specks or gels, what happens when you're running clear parts, scrap on startup after a shutdown, hot runner die cleaning, and screw pulls. Just a little purging 101. As everybody knows, what typically happens, and this is a very rudimentary example, material inside your plastic processing equipment is always going to take the path of least resistance. So what typically happens over periods of time, let's say if you're, and I'll use a very simple analogy here, if you're running polyethylene and you're doing multiple color changes, what's going to end up happening is you're going to develop layers internally within the system on the walls of the barrel, the screw, flights, etc. We see this all the time. I might go into a plant to help with a black to white or black to clear color change. And once we put the purge compound in, not only do we get the black out, but we might see colors that you hadn't run in months. I mean, there's been several occasions where I've seen a yellow or a green or another color come out that they hadn't run in a very, very long time. Again, accumulation of layers will develop on the flights, barrel wall, check ring, and the nozzle of an injection molding machine. Same thing happens whether it's extrusion, blow molding, or any type of extrusion application. There's always hang-up areas that present the biggest challenges. Okay, this is a typical example of what we've been able to accomplish. This is an injection molding case study doing a color change. You can see what we would call on the left side of this. They're running a white polypropylene to go into a clear. And their normal time of getting that accomplished would be an hour and 45 minutes. We take a look at the machine running cost, current downtime cost, and we come up with a bottom line number where this color change is costing this injection molder approximately, well, in this particular case, $871.50. After we use the Asaclean purge, we reduce the time from an hour and 45 minutes to 30 minutes. We used 350 pounds of material versus 80 pounds of Asaclean. If you take a look at just the bottom line on the cost per changeover, we reduced it from $871 to $496. And if you take a look at after amortizing that out, the money and the cost savings add up dramatically. You know, if we're doing 5 changeovers per week, 48 weeks per year, annual savings is $90,000 or 43%. And we were able to give them back 300 hours of valuable productivity. So you can see where purge compounds can have a huge effect on your bottom line. Second thing, black specks or gels. These pictures depict what happens if you were to leave ABS in your system at 460 degrees for a period of time. You can see after 1 hour, the ABS begins to degrade pretty well. After 5 hours, it's pretty well gone. And in the bottom picture, after the heaters are turned on and purged with the next resin, you can see that in this particular case, it was polystyrene. You can see that the polystyrene has coated the degradation, but hasn't really removed it. And over a period of time, that's going to continue to build up and create black specks. On the right side, where you use the Asaclean that's left in the barrel, the top photo will show you that the ABS is completely gone. After 5 hours, obviously, there's nothing happening whatsoever. In the last frame on the bottom, you'll see that once the Asaclean is displaced with, in this case, polystyrene, the screw is like it came out of the box, free of contamination. Clear parts. Clear needs to be clear, guys. Any types of specking, streaking just cause rejects. When we're talking about clear parts, this is one application where the concentrate version that we have really comes into play. Whether you're molding an acrylic, a polycarbonate, a styrenic, any kind of clear materials, you can mix our concentrate with your production material to maintain the machine to keep it free from black specks, using it on a shutdown or during your processing. If black specks do appear, you can use the concentrate to remove it. I don't know if you're aware of this, but most purge compounds are either styrenic or polyethylene based. And if they have a polyethylene or styrenic carrier resin, when you use them, they don't necessarily go well with clear products. You could remove contamination, but then the issue becomes removing the purge compound out after the purge process, so you do get back to a clear part. Again, this is a adaptation of how quick an ABS can degrade on a shutdown. Obviously, if you take a look at the start, it's nice and pristine. Just after 15 minutes, that ABS at 460 degrees is going to begin to degrade. After 30 and 60 minutes, you see what the outcome is. And that's just due to time and temperature. If you were to leave an ABS in the system, let's say on a shutdown, and go to cold steel, well, obviously that steel is not going to drop down to ambient temperature immediately. It's going to take a period of time. And within 60 minutes, and we all know that it's going to take longer, that for that to go to cold steel than 60 minutes, you can see what happened. So getting your production material out of your system effectively as quickly as possible on shutdown before you go to cold steel is extremely important. That's where purge compounds come into play. Hot runner and die cleaning. Whether you have multiple drops, just a few drops in a hot runner environment, high cavitation molds, getting the material out of the system effectively or performing a color change is extremely important. We have grades that will handle gate sizes down to 20 thousandths. So if you are having problems with hot runner tools with high cavitation, we'll have a purge compound formulation to handle that. When it comes to extrusion or die cleaning or head cleaning, again, the chemical purge compounds are much more effective in that application. They foam, they expand, and they get into the negative flow areas and dead spots very, very effectively. When it comes to chemical type purge compounds, in some cases, we're going to ask you to heat the machine in certain areas. We typically ask you to heat or apply additional heat in areas after the screen pack, melt tube, static mixture, melt pump, and of course the die. And we do this for a couple of reasons. Chemical purge compounds are heat activated. They typically begin the chemical activity around 360 to 380 degrees. But for every 30 degrees you add, the chemical activity almost doubles. At 550 degrees, you are getting the most chemical activity out of the product that it can generate. And it's also time released. So let's say if we are purging an extrusion system, typically in extrusion, we're not seeing a lot of the problems in the extruders themselves. They're always downstream in melt pump, static mixers, die, feed block. Those are the areas where we're going to increase heats. So in the extruders, we would keep those at operating temperatures, increase heats where we need to, because we don't really want to set the purge compound off to its maximum capability in the extruders where you don't need it. We want it to happen downstream. So that aids in the cleaning process extensively. Again, when we're talking about hot runner and die cleaning, there are considerations that we need to make sure of. Number one, we're going to determine if the best solution is a mechanical or a chemical type purge. We're going to make sure that we use the step-by-step instructions. We're going to understand what the clearances, die gap, and gate sizes are. We're going to put the problem where the heat is, and we're also going to deal with shutdown and sealing. Another case study on using plus grade, which is the concentrate, on a hot runner color change. In this particular case, it was 13 and a half hours running 2,557 pounds of material. Obviously, all the cost structures are there, and cost per changeover, their current way at that particular time, was over $4,000, almost $5,000 in taking 13 and a half hours. When we took and used the Asaclean, we were able to reduce that changeover by 5 hours to 8.5 hours. And the bottom line cost associated with using the purge compound was $2,409 using 15 pounds of purge. Again, amortizing that out, 3 changeovers per week times 48 weeks per year, overall savings in that particular case was 58% or over $358,000. Time saved, 720 hours of valuable productivity we were able to give back to this client. Material saved, 75%. Pretty impressive numbers. Screw pulls. Guys, anybody pulling a screw, you have to pay close attention to this. We have a product that's called Asaclean EX. I don't say this cavalierly. It's the best product on the market for that. Not only because I represent the product, but I actually had to compete against it when I was with my former company. And there's nothing that touches this product for a few reasons. Number one, it's extremely easy to use. It's very, very cost effective. And I have a very short, brief video that I'm going to share with you. It's only 90 seconds. And you can also find this video on YouTube. If you were to open up YouTube in their search bar, just simply plug in Asaclean EX. You can access it that way. And after this presentation, if you wanted to share that with some of your team members, that's a perfect way for you to access it. So, Derek, if you wouldn't mind, if you could start the video, I'll explain it a little bit. Okay. Now, you're going to notice first and foremost that this is a small tabletop extruder or screw and barrel. Guys, I've put this in extrusion situations where the screw was 6 inches in diameter and 24 feet long, and it works exactly the same way. As you can see, without a purge compound, removing a screw, even of this size, is pretty hard. It's pretty difficult to pull out. You can see how in this particular case, the ABS is really in between the flights of the root of the screw. Pretty sticky. After running the Asaclean EX through the system, you're going to notice a couple of big differences. Number one, the screw is going to be much, much easier to pull out of the machine. Very, very little effort, and whatever the size of the screw doesn't really make that much of a difference. Here's the fun part. The purge compound will peel off the flight in the root of the screw just like a banana, taking everything with it. So guys, there's no reason to have to use a wire wheel or a wire brush and have to spend hours on manually cleaning the machine. A lot of time, and let me point out, it's not necessary to always have to pull the screw. What happens in a lot of cases is once our clients or customers develop enough confidence in the product after pulling it once or twice, they know that it's going to be clean. So they'll just simply follow the Asaclean EX with their next production material to displace the Asaclean EX. Very cool product, time saving. It is glass filled and really, really gets the job done effectively. Here's another case study on a screw pull. Just take a look at the changeover time, guys. The 12 hours in this particular case to manually have to pull and clean that screw. $85 an hour. Machine downtime cost is over $1,000. With using Asaclean EX, less than 30 minutes. Downtime cost $21.25. We used 3 pounds of material in this particular case. Our cost using purge compound was $42.25 versus their cost of 12-hour manual tear down and clean. Savings was astronomical. Not to mention giving them back valuable productivity and production time. Again, 95% annual savings. Total time saved 141 hours. Remarkable. Okay. So having given you a little bit of background on what we do and how we do things, I'm going to take it a little bit step further and explain to you the steps on how we do implement a purge program. This is what to expect, guys. We're going to have an introduction, get to know each other on what you do and how you do things. We're going to diagnose your situation. We're going to provide you some no-cost material to test. We're going to determine when we can test the product. And we're going to do this a couple of different ways when it comes time for you to test the product. Either we're going to ask you if it would be okay for us to come to your plant and technically support the material in person, or if that's not feasible for whatever reason, what we normally do is we schedule a Teams call to review best practices with whomever's going to be putting the product in the machine to give you the best chance for success. We're going to do a side-by-side cost analysis, which I'm going to get into shortly. And then after we develop a baseline of performance with the use of our purge compound, we just don't drop the ball and let you go on your own. We like to maintain contact with you guys to make sure performance levels are maintained and make sure that the product is constantly meeting your expectations. Getting started. We're going to consider the application, the machine, count and size, production and your quality issues, understand your temperature and resins, and we're going to choose a compatible purge. This, guys, is a really, really cool document. We call it a cost savings analysis. Now, this is something that we can provide to you folks, and it's a living document. On all the case studies that I previously showed you, we have a left side, which is the current purge method that you're doing, and we give you all these different things to pay attention to where you can plug in the current values. That's what you do currently. And we're going to come up with a time and cost associated for your current method. After we do the purge testing, we're going to complete the right side of the CSA, which is the Asaclean side. We're going to put those values in. Once all the information is entered, we're going to hit enter, and then we're going to come up with a cost savings analysis with a bottom line figure. Let's face it, guys, purge compounds do cost money. So somebody's going to want to look at the numbers. What did the purge compound generate in savings? This is a very quick and easy way, a one-sheet form that will enable you to provide that to either your production manager, purchasing person, or whomever to show you exactly what the purge compound was able to generate. How to use purge compounds correctly. Again, we're going to understand all the purge compounds are different and have different instructions in different situations. Different purge compounds are best at different things. So that's where we're going to determine a mechanical or a chemical or a concentrate type purge. And then working with us, we're going to understand what the baseline is before we start using Asaclean, and then after we use the Asaclean to develop your purge program. Other benefits for using purge compounds. They improve safety. They increase your machine capacity. Maintenance cost. Improves resource usage. Boosts your first pass yield. Protects the environment and reduction of plastic waste. And reduction in overall cost of material. The myth of costly sustainability. Moving towards a greener future doesn't have to break the bank. In fact, you stand to gain, not lose, with purge compounds. We're saving money by reducing the cost tied to downtime and maintenance. We optimize your performance for quicker turnaround and higher throughput, and minimize waste and make the most of your resources. That's it, guys. This would normally be the time where I would ask for any questions or comments. And typically in one of these 1 hour sessions, hands go up frequently. There are a few questions that we normally get. And guys, Derek, if you'd be kind enough to mention some of those questions, I'll be happy to answer them.
Absolutely, Chris. The first question we have here is, what was the name of the grade in that screw pull video?
The name of the grade is Asaclean EX. E like Edward, X like X-ray.
Perfect. And then are purging compounds safe for hot runners?
Yes, they are. One of the reasons why is if you were to use a chemical type purge compound, chemical purge compounds only emit carbon dioxide and water vapor in their chemical reaction. So there's no type of odors or fumes that are offensive or harmful in any way. Chemical purge compounds particle size is submicron in its melted state. So in the case of chemical purge compounds, whatever the gate size is, chemical purge compounds don't have an issue. Mechanical purge compounds, same way. All of our purge compounds are recognized as safe by the FDA.
And do you have any options for people in blown film extrusion?
Absolutely. Over the past few months, I've been working exclusively with blown film manufacturers out in the Midwest. Chemical purge compounds such as Asaclean N, like Nancy, C, like Charlie, and like Robert, NCR, have been extremely helpful. Typically, the problems in blown film applications are the die lips, the spirals in the die. Chemical purge compounds help alleviate any contamination, color, or material buildup in the most inappropriate areas to get to.
Is someone available to help me build my own purging program? Is that free?
Yes, it is free. And not only myself, but there are 9 other members of our team that do what I do. We are all regionally located. So wherever you are in the 48 contiguous states of the United States, we do have a regional rep that can help you out and accomplish all the goals that we just mentioned throughout the day. And again, it is free of charge. Not only that, but you will get no cost material to test and compare as well.
And what are the best applications for the concentrate grade?
Best applications for concentrate are several. Obviously, as we mentioned earlier in the presentation, clear parts, always good to have a concentrate grade, so you don't have to worry about a carrier resin in the purge compound. We're going to mix that with your production material. So not only will you get a very good cleaning, but it will be easily displaced with your production material because that's what your carrier resin will be. In the case of blow molding, like I had mentioned, most blow molders are buying and using polyethylene. There's no reason for you folks to buy our carrier resin. You have your own. And again, you can up or decrease the ratio of purge compound to your carrier resin, depending on your situation. Concentrates are also good for various types of resins when being used as shutdowns. But guys, you can use a concentrate in almost every single place where you can use a ready mix. The only place where we do not suggest you use a concentrate is when you're talking about a temperature sensitive resin, such as a PVC, an ABS, or those types of materials.
Perfect. Well, that brings us to the end of the webinar today. Thank you all for attending today's webinar. Just as a reminder, we will send you a link to the recording of today's webinar so you can watch it anytime and share with others at your company. That should already be in your email box. Asaclean has provided an email for questions, so please feel free to contact them for any questions that you may have. Thank you again for attending today's webinar and have a great day.